All right, guys, today we're going to be talking about graphing relationships, being able to analyze a graph, and also talking about the difference between independent and dependent variables. So we're going to zoom in on this first example here. And they tell us in the problem that a person is deciding to go for a run. They're going to take breaks at certain points. The person's distance from their house is shown in the graph below. When you're looking at these graphs, it's always a good idea to take a look and see what the x-axis represents and what the y-axis represents. So the x-axis is representing the time. So as we continue to the right, the time of their run is increasing. On the y-axis, as the y values get larger, this is them getting farther from home, as it's the distance from their house. Farther from home, which is different than if it's going down low, they're closer to home. So a low y value is a distance close to home. A high y value is a distance that is far from home. You'll notice that this graph is a continuous graph, but that it has different slopes along the way. Those different slopes represent different things that are occurring on this person's run. So first thing I want us to do is compare segment 1 to segment 2. Segment 1 to segment 2. We're going to compare and contrast by finding similarities and differences. So let's zoom in on there. Find how they're the same and how they are different. Now you'll notice one thing that they have the same is the kind of slope that they have. What kind of slope do they both have? You should recognize that they both have a positive slope. So what does that mean in the context of this problem? In both of them, they have a positive slope. The y values are increasing as the x value increases. So what does that mean about their distance from home? Well, in both of them, they are running away from home. So their distance from home is increasing in both. While they both have a positive slope, you might notice that one is shallower than the other. So segment 1 versus segment 2 is steeper. Segment 2 is shallower. So if it's steeper, that means they're leaving from home at a faster rate. Getting farther from home at a faster rate for segment 1. And the shallower curve represents them slowing down. Now, are they still running? Sure. Are they still leaving home? Sure. But they're just slowing down a little bit. Look at segment 4. Next one we're going to look at is segment 4. Think about what it could possibly represent. You'll notice that time is increasing. The x values are increasing. However, is the distance in miles from their home changing at all? No. So at this point, hopefully you're thinking that they are either taking a break, maybe they stopped to get water, maybe they made it to their destination on their run, maybe they were running to a lake and they're just like taking in the views, but they are not running. That's the key idea. Now let's take a look at segments 5 and 6. 5 and 6. We're going to compare and contrast them just like before. How are they the same versus how are they different? And check this out. They're the same and that they both have a negative slope. The negative slope means that time is increasing, but what is happening to their distance from home? It's going back down. So they are both, and both of them, they are running home. However, if we're going to talk about their differences, in which one of these are they running faster? Segment 5 or in segment 6? In segment 5, the graph is dropping at a steeper rate, meaning that the distance is getting closer to home faster in a shorter amount of time. So they are running faster in segment 5 because it is steeper. So if we are asked in this bottom section to explain how the slope of each segment is to the distance from the house and the person's movement, we can say that the steeper slope means that they are running faster, whether that be towards or away from the house. Shallower slope, on the other hand, means that they slow down. They're not covering as much ground in the same amount of time. In this next example, we have John, Gary, and Angela all driving at different rates. We know John is driving at a constant rate of speed. Gary starts out slow, but then gradually builds up speed. Angela starts out fast, but then slows down. 3 graphs of the situation are shown below. I want you to pause the screen and try matching Gary's graph with his driving, John's graph with his type of driving, and Angela's graph with her type of driving. First one we can knock out of the box is John. John is driving at a constant speed. Constant speed means it has a constant rate of change, meaning a constant slope. It's not changing over time. You should have matched graph C to John's description. Gary, on the other hand, starts out slow and then gradually builds up speed. So we should be looking for a shallow slope that then speeds up and gets steeper. For Gary, you should have matched graph B. He starts out slow, but then increases quickly. So Gary is graph B. And finally, we know that Angela starts out really fast, so we should look for a steep slope, but then she slows down, so a shallower slope. That goes with graph A. She starts out, her distance increases really quickly over a short amount of time, but then her distance does not increase as quickly. So we know that graph A goes with Angela. This example 3 is actually on the back, so we'll continue on there. In this final example on graphing relationships, we're going to actually create a graph on our own. So we're going to work on labeling the x and y axes and putting in the appropriate slopes changes on the graph. So let's read this example. It tells us Zoe is tired after a long day of work and decides to take a bath. She at first just turns both the hot and cold water taps on. After 3 minutes, she turns off both taps. After letting the bath cool for 2 minutes, she gets in the bathtub. She stays in the bathtub for 30 minutes. She then gets out of the bathtub, and then she unplugs the bathtub. Our first thing to figure out is what we should label our x and y axis. What is driving the change? Obviously, she's taking a bath. X-axis should represent the time. X-axis often represents the time. The y-axis, on the other hand, as time goes on, what is changing in the bathtub? You should recognize that the height of the water is changing, so let's label that. Now let's see if we can put a actual function on this graph. At time 0, the height of the water is 0. She at first turns both the hot and the cold water taps on. If you turn both taps of water on, you're going to have a lot of water coming in that tub. So the height of the water compared to the time should be fairly steep. After 3 minutes, she turns off both taps. So at 3 minutes, we're going to have some sort of change. She's going to let the bath cool for 2 minutes. So if she's going to let the bath cool there's going to be no change in the water over a little short segment of time. So after 5 minutes, the height of the water hasn't changed. She's just letting it cool. She then gets in the bathtub. That should not change. The time is going to change very little, but think about what's going to happen to the height of the water if someone gets into a bucket of water. You should recognize that it goes up. So the height of the water is going to increase a little bit. She stays in the bathtub for 30 minutes. When she's chilling in there, assuming no water's leaking out, we can assume that we flatline again. It's going to remain constant for a long amount of time. She then gets out of the bathtub. It means the water's going to go down. And then they tell us that she drains the tub. So there's some sort of change at this point, and she's going to drain the tub water out. The last thing I want y'all to do here is label each section. So in our first section, this is the bathtub filling up. And then why did it get constant here? She was letting it cool off. In this next positive region, she gets in. At this whole leveling off period, we can say she's chilling out. Hopefully not chilly, but she's just hanging out there. That last, second to last section, she gets out. And then in the final piece, the tub is draining. You'll be practicing drawing some graphs on your homework tonight as well. So make sure that you, first things first, always label your axes so that you can come back to, always look back at the story and try to think about how those two are comparing at any section of the story. Let's take a look at independent and dependent variables next. For independent and dependent variables, I first want you to brainstorm in your head and on your notes and try to remember, or try to just think about what these two words, independent and dependent words, mean to you. In math and in a lot of subjects, independent and dependent variables are used often. The independent variable, just like the word that you just brainstormed about, is the variable that causes the change. So this arrow is going to represent our change. What you need to know is that the independent variable causes the change to occur. So it's the driver of the change. So the independent variable causes a change, and this results in the dependent variable changing. So the dependent variable is reliant upon the independent variable for it to change. Kind of like in the example above, time was our independent variable. Time was going to change regardless. The time, as it went on, changed the height of the water. In math, the x variable is usually the independent variable. The y is the dependent variable. In these next few examples, we're just going to practice finding out what is the independent variable, the one that's driving the change, and what is the dependent variable, kind of the resultant variable. Example number 1, you're going jogging. For every mile you run, you burn 100 calories. The independent variable, what is causing the change? That would be the number of miles you run. That is affecting something. The more miles you run, what's going to change? The number of calories you burn. Pause the screen and try out those next two on your own. You are doing chores to earn your allowance. For each chore you do, you earn $3. Similar to the one above, think about what is driving the change. The number of chores you do. That is going to affect the amount of money you earn. And in our final one, if you haven't done it, pause the screen and try it on your own. You are studying for your next quiz. The more minutes you study, The higher your grade will be on that quiz. The independent variable is the number of minutes studied. That's going to affect your grade, which is the dependent variable. You'll be practicing both independent and dependent variables and graphing relationships on your homework tonight. Rewind and watch anything that might have been confusing.